Hey Tube, welcome back. Problem number 200, number of islands. So given an M and N 2D binary grid, which represent a map of ones and which is lands and zeros, which is water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water. So, for example, we have this one as an example. I guess we have only one island because if we connected all the ones, we will see we have only one island if we connect all the ones. Here we will see that we have three islands. We have this four, and we have another one here and another one here. So we have uh, um, three islands. And whenever we get a grid, we need to know how many islands do we have. So how could we solve this problem? First, to solve the problem of counting the number of islands in 2D grid, we can use a depth first search or breadth first search as well. The idea is to traverse the grid, and whenever we find one, which is a land, we start a depth first depth first search or breadth first search, whatever you prefer, to visit all connected lands and mark them as visited. And each time we start a new depth first search, it indicates that we have found a new island. So we will do right there. First, we check if this is one. If this is a 1, and if it's 1, we'll try to make another search to try to search for all its neighbors and recursively do that one by one to discover all the neighbors. And whenever we find them, we mark them as visited, and also we increase the count by 1. And after that, whenever let's say that this is not 0, this is 1. So if that was the case, we will have two islands because we continue in the depth first search and visit each item, and when we find one and it's not visited, we will increase the count by 1, so we have two islands, not one. So this is what will be the solution. So let's see how we will do this in the code. So first, let's just make some base cases. So if we don't have a grid, or the grid dot length equals 0, we return 0. Okay. Right now we need to create a depth first function that will take two arguments, which is I and j. I would say if I less than 0 or j less than 0, if that was the case, or I bigger than or equals to rows, before doing rows and stuff, let's initial some variables. I need to create variables. I will need to create a rows variable will equals to a grid dot length, because it's a 2D array. So we have right now we have 4 rows, grid dot length, and we need to create columns, and the columns it will equals let's call it columns. It will be calls. It will equals grid the length of 0, not like that. Grid of 0 length, and we need to have a count which equals 0. So if we need created depth first search, and we need, and it will be a recursive function, and whenever we have a recursive function, we need to think about the base cases, or the basis that when we have to stop the searching. So when I is less than 0 or j is less than 0, so if the index is -1, or I is bigger than rows, because I will represent rows. If I bigger than rows, that means there's no rows else to search in. Or J is bigger than or equals to the columns. Or what else? Or grid of I and J, the node at this position, is not 1 actually. It's equals to 0. If that was the case, we should return nothing. Like we just return nothing. And yeah, not like that. This one. Yep. Yeah, exactly. This one is way more better, I guess, in my opinion. And if that was the case, oh, no. This is not right. We return nothing. Yeah, this is right. And after that, we need to see if we need to mark like if I is not 0, if J is not less than 0 as well, and I and J less than the rows of columns, and the actual node that we're trying to reverse or read is not 0, it's 1. So first we need to mark it as visited. So what we will do, we will change its value to 0. So we will say grid I of J should equals 0. And by then we mark it as visited. And after that we will, let me just, no, it's not better right now. Yeah. After that, we need to visit all the adjacent cells, up, down, left, and right, because we have up, down, left, and right. How we will do that? First, we will call the diffs again for the up. How we will call it for the up? Let's say that we are here. How we do the up? We are going to go a row in the up. So how we'll do? Let's say that the row is right now we are in the row of 1. We will go in the row of 0. So let's say it will be I minus 1, and we continue with J. So right now we are visiting the up. After that, we need to visit the down. So we will do the same, but it will be I plus 1, and we have J. We need to visit the left and right. So the left, dfs, it will be left, it will be I and J minus 1, because we're going left, and dfs, it will be I as well and J minus 1, because we're going right. Okay, we created the diffs function right now, the diffs first function that should search. After that, we need to create a for loop. So let I equals 0 and I less and I less than rows, and I plus plus. Okay, and we can create another for loop. Let J equals 0, J less than columns, less than calls, and J plus plus. And right now we need to say if the grid I of J equals 1. If that was the case, we will count, we increase the count to be plus plus, and we will see if actually it's and we will try to visit all its surrounding node. So we start at depth first search to mark all the connected lanes. So we put I and J, and in the end we should return the count, and it should work perfectly. Let's submit and see. Okay, it's not working. Why it's not working? Unexpected token, why? Holy sh... const should equals... It should be an arrow function. I don't know why I did that. Yeah. Did I did something wrong? I know. What's going on? Let me refresh again and see. If not grid, grid is not defined. Grid not good. Okay, it's working, but I'm beating. Let's try to submit again to see if... Yeah, I'm beating 87%. Okay, this is way more better, to be honest. Okay, so first we have a base check. We ensure the grid is not empty. After that, we initialize the variables. And after that, we create a depth first function. We check the boundary conditions and the base cases to stop the recursive function. And after that, we recursively visit all 4 adjacent cells. And at the end, we traversal loop through each cell in the grid. And when we found one, we increment the island count by 1 and start a depth first search to mark all the contact islands. In the end, we return result after traversing the entire grid, and we return the total count of the island. So that's it for this video, and I hope you like my content. If you like my content, subscribe and hit the notification bell so you'll never miss a video, and see you in the future.